Once you have talked about that, now we shall talk about the hardness of the water. There could be the temporary hardness of the water and the permanent hardness of the water. We shall talk about that. So over here, now let's talk about the hardness of water or water hardness. Hardness of water, right? So there could be two methods. One could be the temporary hardness and another one could be the permanent hardness, right? If we talk about the temporary hardness, right, then we shall say that it is due to the presence of calcium and magnesium bicarbonates. So very, very important, please remember that it is due to the formation of calcium and magnesium bicarbonates. Repeatedly asked, guys, that's why I'm just emphasizing on this point, that it is due to the calcium and the magnesium bicarbonates, temporary hardness. Permanent hardness comes due to what? Permanent hardness comes due to the nitrates, due to the sulfates, and due to the chlorides. So it comes due to sulfates, nitrates, and chlorides. Okay, so please do remember that as well, that permanent hardness and the temporary hardness, what are the factors which are responsible for causing this particular thing, right? One more thing I would like to add over here, that 1 milliequivalent, right, 1 milliequivalent per liter of hardness tells us about 50 milligram of calcium carbonate in 1 liter of water, right? If there is 1 milliequivalent of hardness, it will be telling us about the 50 milligram of calcium carbonate of hardness in the water, right? So that is very, very important, because sometimes they are asking you that if it is 3 milliequivalent per liter, then how much milligram of hardness it is telling us in the 1 liter of water. Then obviously our answer will be 150 milligram. Why is it so? Just multiply it with the 50 and that's how we will be getting our answer, right? According to that, we shall talk about one important classification, guys. We shall talk about now one very important classification over here. Classification of what? Classification of the water hardness, right? Classification of the water hardness. So here we shall talk about at what level we shall say that this is the hard water, or this is the soft water, or this is the very hard water. Okay, these kind of things. So here on one side I am writing the hardness levels of water, obviously, and here the unit which we will be using over here, that is a milliequivalent per liter. Okay, on another side we are writing let's say the amount of ion that is actually producing the hardness, ion that is actually producing the hardness. Okay, and here the unit which I will be using over here, that is the milligram per liter, right? So now let's talk about that. It's very simple, guys. Just remember this particular table. Sometimes very frequently they might ask you these kind of questions, right? So let's say at what unit, at what levels we'll be saying it is a soft water, right? At what level we'll be seeing it is the moderately hard water, right? Then there could be the hard water and very hard water, right? So hard water will be saying if the hardness value will be in between 0 to 1, or we can say it is less than 1, right? If it is 1 to 3, then it is the moderately hard water. If it is 3 to 6, then it is the hard water, and if it is more than 6, then it will be the very hard water, right? Please do remember that. And I told you that 1 milliequivalent per liter will be carrying the 50 milligrams of hardness in the 1 liter of water. So that is the thing, 50 milligrams in 1 liter of water. So just multiply it with 50. 1 into 50, it will be the 50 milligrams per liter. Okay, then I can say 50 to 150 in the next one, 50 to 150 over here. Then I can say 150 to 300 over here. And if it is more than 6, then it will be more than 300 over here, right? Very simple. So that's how we can just classify this particular table. Okay, please do remember this particular table. Take the screenshot of this particular table. Okay, it is very, very important. Definitely that might be tested, right? So you just need to remember the hardness levels, and that's how you just multiply it with the 50 and you will be getting the amount of ion which is producing the hardness. Okay, because sometimes they might ask you what amount of ion might be produced if we are talking about the very hard water. So in very hard water, it means they are talking about more than 6, it will be more than 300 in that particular case, right? So these questions might be asked over here. For drinking water, what kind of water you are drinking? This is this water. Moderately hard water is adequate for drinking, guys, not the soft water. Okay, don't go with that rule. Moderately hard water, 1, 2, 3, if it is there, between 1 to 3 hardness is there, then at that this is called as a drinking water. So what is the drinking water? That must be moderately hard water. So drinking water is the moderately hard water. First point over here, drinking water is moderately hard water. Moderately hard water. Okay, so please do remember that, moderately hard water, right? So that might be asked that what particular what kind of water you are actually drinking. That is a moderately hard water. When you will be needing the softening of the water. Softening of the water you will be doing when the hardness of the water will be going beyond 3 milliequivalent per liter, right? It means that if it is coming to the hard water category, then you will be start doing the softening of the water, right? Now we shall talk about one important point, that is about the treatment or removal of hardness of water. How you can remove the hardness? First of all, for example, if it is going beyond 3, hardness of water is going beyond 3 milligram per liter, so obviously it is not suitable for the drinking, right? It is coming now in the category of hard water, not the moderately hard water. Now it is coming in the category of hard water. So now you need to do the softening of this particular water. How you will be doing the removal of, how you will be doing the softening of this particular water? How you will be removing the hardness of this particular water, right? So let's talk about that as well. One option is that you might actually go for the boiling method, right? But boiling method at the same time, it is actually expensive method, right? Boiling method is expensive method because you will be needing a lot of LPG gas to boil the water, right? Then next method which we shall use over here, that is the addition of lime. Why I'm telling this? Because they will be asking you overall that which of the following method can be used for the softening of the water or cannot be used for the softening of the water. So for both of these questions, this particular table will be serving the purpose. So boiling, lime addition, then you can be adding the sodium carbonate, guys. Sodium carbonate addition might also be done for softening of the water, and base exchange process might also be done. Once they had asked us the question that which of the following is not helpful in softening of the water, right? The options were base exchange process, addition of soda lime, sodium bicarbonate addition, and the next option was filtration. Obviously the filtration is not the option. The filtration is the correct option in this particular question, because filtration is not the method which is causing the softening of hardness of water. Other methods are causing that. Other methods are doing that. Okay. Now, what are the biological parameters, right? We have talked about the physical parameters overall. Chemical parameters, we have talked about the detail, the chlorination. We have talked about the breakpoint. That was the highlight of this particular session. And then we have talked about some of the methods that how we can actually check the levels of estimation. Right, levels of estimation of the residual chlorine. We have talked about two methods, orthotoluidine test and the orthotoluidine arsenide test. Then we have talked about the hardness of the water, temperature and the softness of the water. In the chemical parameters only, we were talking about all these many things. Now we are coming to the last one, that is the biological methods, right? Guys, now let's talk about the biological methods as well. In the biological methods, we shall talk about one important test over here. Just remember the name of the test that will also serve the purpose. That is the coliform test. Actually, this coliform test we are using for what? We are using for assessing. This is the most sensitive tool to assess the contamination of the water. This is, guys, what I'm saying is that this is the most sensitive tool, or you can say the most sensitive test, right? It is the most sensitive test to assess the contamination of the water. And what it is actually assessing? Coliform test. Coliform. Can you remember some bacteria out of it? Coliform, coli, E. coli. Yes, E. coli. So, which bacteria I'm talking about over here? This is the E. coli, right? So, E. coli, I would say, right? I shall write over here that E. coli is the most sensitive. E. coli is the most sensitive, right, to assess the contamination of water. To assess the contamination of water. Okay, this is the biological method, right? Then what about some of the radiological methods, right? One more thing over here which I would like to add. Okay, so it is actually done by the McCartney chart method. McCartney chart method. Okay, just remember the name in case if it is coming. Okay, once it was asked in the PG exam. Then we shall talk about some of the radiological aspect, right? Now let's talk about the radiological aspect of quality of water. Obviously of water quality, right? just two things you need to remember over here, right, about the radiological aspect. One is about the alpha activity and other one is about the beta activity. We know the unit of radioactivity is the becquerel, right, if you guys remember. So here we shall write that one about the alpha activity and another thing about the beta activity, right, alpha activity and the beta activity. If we talk about alpha activity over here, then we are saying that it should be less than 0.5 becquerel. This is a sign of becquerel, right, BACQUEREL, okay, becquerel per liter, okay. And if it is less than 1 becquerel per liter, if I am saying that less than 1 becquerel per liter, then it is for the beta activity, right. So here what we are saying, alpha activity and the beta activity, right. Alpha activity, it is less than 0.5 and beta activity is this, it is less than 1 becquerel per liter, right. So that was about the several aspects of the water. Basically we have talked about the physical, chemical and the biological and the radiological activity of the quality of the radiological parameters for the quality of the water. In the physical one we had to talk about the color of the water, odor of the water, turbidity of the water. In the chemical one we have talked about the chlorination of the water, hardness of the water and some other parameters, the test over there. In the chlorination, the highlight point was the breakpoint of the chlorination, that before the breakpoint there was a formation of chloramines and the destruction of the chloramines. After the breakpoint there was a formation of free residual chlorine and combined residual chlorine, and in total they were making up the total residual chlorine. Then we have talked about the methods to estimate the levels of these residual chlorines, that was the orthotoluidine test and the orthotoluidine arsenide test. Then we had to talk about the hardness of the water, in which we have talked about the temporary hardness and the permanent hardness. Temporary hardness, I told you that we are having some components in it, and the bicarbonates, mainly the calcium and magnesium bicarbonates. And in the permanent one I told you that there could be the nitrates and the chloride ions, okay, that might be needed over there. Then we have talked about the the radiological and the biological method. In the biological method we have talked about the coliform test, right, that was done by the McCartney chart method. And the radiological aspect, alpha activity, beta activity, what are the units about that, right. So that was about a quick recap of this particular session. I hope you enjoyed the session. After this we'll be talking about one more thing, that is about the other remaining part of the chlorination of the water, right. We'll be talking about other methods. For an example, we'll be talking about the what are the tanks which we are using for the storage of the water and all. We'll be talking about that thing in the next session, so please stay tuned. And after that we'll be talking about the combined MCQs of this water section, right. So stay tuned. I'll be seeing you in the next one. Thank you.